Hello students, today I am going to start chapter 7 of your textbook, that is coordinate geometry. Even in class 9 you have done this chapter. Now let me just revise. In coordinate geometry we draw two perpendicular lines in a plane. The plane is called Cartesian plane and these lines are called x-axis and y-axis. The first line we write x, o, x prime, and second one y, o, y prime, and they are perpendicular to each other. The point where they intersect, this point is origin. We represent it by symbol O and its coordinate is 0, 0. This room or this quadrant is called first quadrant, this one is called second quadrant, this one is called third one, and this one is called fourth quadrant. Now suppose in this Cartesian plane you are having a point like this and you have to find the coordinate. This system is called coordinate, so you have to find the coordinate. For this you have to start from origin. First of all we have to move along x-axis 1, 2, 3 places. That's why we have written 3 here. And along y-axis you have to go 1 unit, then 3, 1. Fine. So this 3, 1 we have to write within first bracket. This is the coordinate of this point. Now suppose we are having this type of one coordinate plane where many points, some points are there. This point is from this is one is origin. We can represent it by the symbol O. 1, 2, 3, and here 1, 2. So 3, 2. As you can see, both the numbers are positive. That means whenever both the components are positive, it will be in first quadrant. Now you see in the second quadrant, suppose one point is here. Here it will be -4 and here it will be +2. So coordinate of this point will be -4, 2. First one is negative and second one is positive. Here we have considered this point, suppose -3, -2. As you can see here, -3, -2. So this one is third quadrant. In third quadrant both the components will be negative. And here in the fourth quadrant we write like this, plus, minus. This point is 3, -2. So first component will be positive and second component will be negative. I have drawn x-axis here and y-axis here. After drawing, suppose if I see the coordinate of this point will be 1, 0, because from this origin we have to move 1 unit. Along y-axis no need to move, so 1, 0. For this point along x-axis I have to move 2 units, along y-axis no need to move, so it will be 2, 0. That means any point in x-axis will be of the form of x, 0. That means its abscissa will be something but ordinate will be always 0. So we can write any point on x-axis is of the form x, 0. And suppose the point is on the y-axis, this point along x, from here we have to start. Along x-axis no need to move and we have to move along y-axis -2 units. So it will be 0, -2. Suppose the point is here. In that case along x-axis no need to move. Remember we always start from origin. Along y-axis it will be 1, 2 units. So it will be 0, 2. So as you can see, whenever point is in the y-axis, its abscissa will be 0 but its ordinate will not be 0. So we can write any point in y-axis is of the form 0, y. Now suppose we have taken 2 points here. First point is P, x1, y1, and second point is Q, x2, y2. Fine. So whenever we write x1, y1, that means this distance is x1 and this distance is y1. Whenever I say x2, y2, that means this distance is x2 and this distance is y2. So this distance from this point to this point, it is x2 minus x1, and this distance, just see, this whole thing is y2. From R to this part is y1. So this part will be y2 minus y1. So this part is x2 minus x1. This is y2 minus y1. Now just see in this triangle PQR. This is a right angle triangle. Now what is PQ square? Because in this triangle this is 90 degree. So PQ will be hypotenuse. So PQ square will be PR square plus QR square. I think you can recollect your Pythagoras theorem, whatever you have learned in chapter 6. So you have just applied Pythagoras theorem. After that PQ square, what is PR? PR will be x2 minus x1 whole square. And what is QR? QR is y2 minus y1 whole square. So PQ equals to root over, because I am just removing the square, so root over x2 minus x1 whole square plus y2 minus y1 whole square. This formula is commonly called distance formula. In terms of abscissa and ordinate, we can write distance equal to, we know x component is called abscissa, so it is difference in abscissa square plus difference in ordinate square. Fine. Now suppose 2 points are given to you. One point is P, which is 5,8, and second point is Q minus 3,2, and you are to find the distance between them. So we can consider first point 5,8 as x1, y1, and second point minus 3,2 is x2, y2. Suppose you can consider this point is P, this point is Q, and you are to find the distance between these 2 points. Now this is x1, y1, this is x2, y2, and we know distance formula is x2 minus x1 whole square plus y2 minus y1 whole square. Now minus 3 is x2, so as you can see minus 3 minus 5 whole square, 2 minus 8 whole square. This is what I have written on calculation. Minus 8 square minus 6 square, 64, 36 minus minus plus, and it is 64. Here also it is 36. You got 100, and root over 100 is, that means 10 units. Okay, suppose the point is a comma 0 and 0 comma b, then this point will be x1 y1, this is x2 y2. Just use the same formula, x2 minus x1 whole square plus y2 minus y1 whole square. You will get x2 minus x1, 0 minus a whole square, and b minus 0 whole square. It will be minus a square, b minus 0 is b square, so answer is a square plus b square. Here this minus is there, so if you square, minus minus plus, so this is your answer. Suppose question is you have to find the distance between cos theta, 0 and 0, sin theta. These are the points. So let x1, y1 is this, x2, y2 is this. Now what is distance formula? Already you know. Apply 0 minus cos theta whole square, 0 minus cos theta, and here sin theta minus 0. 0 minus cos theta will be minus cos theta square, sin theta minus 0 is sin theta whole square. We know minus minus plus, here it will be cos square, and it is sin square. From the trigonometry knowledge, you know sin square plus cos square is 1, so this part will be 1, and root over 1 is 1. So this is your answer. If the question is, suppose question is one point is 3, a, another point is 4, 1, and distance between the points is root over 10. So just imagine you are having first point is 3, a, second point is 4, 1, and the distance between them is root over 10. What you are to find? You are to find the value of a. Since here distance is involved, we are going to use distance formula. Distance is given in the question root over 10, so distance, you just write the formula equals to distance. Okay, now x2 minus x1, 4 minus 3 whole square, 1 minus a whole square equal to distance is root over 10. 4 minus 3, 1 square. Here 1 minus a whole square, so directly you cannot write, you have to apply the formula a minus b whole square, a square minus twice ab plus b square, here equals to root over 10. So just calculate 1, here 1, 2a plus a square equal to root over 10. So here 1 plus 1, 2, minus twice a plus a square is root over 10. If I take square on both sides, on squaring this root over will go, you are going to get 2 minus twice a plus a square equals to 10. You transpose this 10 in the other side. Now you are having a square minus twice a minus 8 is 0. You can do middle term factorization. Here a square, coefficient of a square is 1. Here it is minus 8. So 1 into minus 8, you are going to get 8. Minus 8, I am not writing minus. 8 I can break in the form of 1 into 8 or 2 into 4. So 2 combinations I am getting. 4 minus 2 is 2. So a square minus, instead of 2, I can write 4 minus 2a minus 8 equals to 0. A square minus 4a minus minus plus 2a minus 8 equals to 0. From these two, you take a common, a minus 4 left. From these two, you take 2 common, a minus 4 left, twice a, and 4 to ja 8. A minus 4, you have taken common, a plus 2 left. So since you are going to get two values, so a minus 4 0 means a equals to 4, and a plus 2 0 means a equal to minus 2. So you are going to get two values of a, 4 or minus 2. Point a 0, 2 is there, which is equidistant from b and c. a point A 0, 2 is there, which is equidistant from B and C. B's coordinate is given 3, P and C is P, 5. Since in the question it is given AB equal to AC, I can write AB equal to AC. Similarly, you can apply distance formula here. In case of AB, you just write root over 3 minus 0 whole square and P minus 2 whole square. And in case of AC, I can write P minus 0 whole square and 5 minus 2 whole square. 3 minus 0, 3 whole square. 5 minus P minus 2 whole square. So I have to use the formula A square minus 2ICB plus B square. P minus 0 is P square. 5 minus 2 is 3 square. 9, P square, 4P, 4, P square, 9. Now you take square, if you square on both sides, the square root will go. So you are going to get P square minus 4P, 9 plus 4, you are going to get 13 equals to P square plus 9. You transpose this to the other side, these two will become minus, negative, this and this cancels. You are going to get minus 4P plus 4 equals to 0. So what you are going to get? Minus 4P plus 4 equals to 0, minus 4P equal to minus 4, P equals to minus 4 by minus 4, so P equals to 1. So that is the required value of P.